Hello everyone, I am audible. Yes, my voice is clear. Yeah, I am audible. Yes, so I hope my screen is visible. Yes, so this is lecture 12 on discrete mathematics, and in the previous lecture we have left with this question of generating function. We will first complete it and then we will start our new topic, that is set theory. Okay, so how we will approach this question? So let me tell you, this is GATE 2022. Yeah, any doubt?
No, sir.
Okay, so this is GATE 2022 question. So let me do it. So what they are saying, numeric function is given to us and they want us to find the generating function. Numeric function is n plus 1 if n is odd, 1 is otherwise. So see this, so this is not a direct question. Okay, so how we will approach it? So let me tell you first that thing. So what is the generating function? Generating function is r is equal to 0 to infinity numeric function into x power r, and we want to find value of this thing. So now numeric function is given to us as a broken function, n plus 1 when n is odd, 1 is otherwise. So let me write the sequence first. Okay, so AR will be what? When 1 is otherwise, n plus 1 when n is odd. So for A0 it will be 1, and then for and then it will be 2, then 1, then 4, then 1, then 6, then 1, then 8, then 1, then 10, dot 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 dot. Are you getting it? A0, then A1 is 1 plus 1 2, A2 will be 1 because it is even, A3 odd, so n plus 1, that means 4. So then A4 it will be even, 4 is even, that's why it will be 1. And then A5 and r plus 1, see this, n plus 1 when n is odd, 1 is otherwise. So I have simply written the sequence. So now we have not done this kind of sequence till now. No problem, we will try to adjust it. So how we are going to adjust it? So let me do it first. Since we have not done this kind of sequence, so let me write it in sigma type of thing. So what I will say, so a0 into x0 na, so I will simply expand it, a0 into x power 0, a1 into x power 1, and so on. So a0 is 1 na, so 1 into x power 0 plus में 2 into x power 1 plus में 3 into x power, sorry, 1 into 1 into x square plus में 4 into x cube plus में 1 into x power 4 plus में 6 into x power 5 plus में and then 1 into x power 6 and then 8 into x power 7 dot dot dot, like this we have to expand. So now I think there is some kind of pattern which we already know, x power 0, x power 2, x power 4, x power 6. You just take these terms. So what we are going to get? We are going to get is x power 0 plus x power 2 plus x power 4 plus x power 6 plus x power 8 dot 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 up to infinity. One is this, then plus, you take them. So what will be that? 2 into x power, so I am simply dividing them, okay? Even terms are different and odd terms different. 2 into x power 1 plus 4 into x cube plus में 6 into x power 5 plus में 8 into x power 7 and so on up to infinity. Are you getting it? So see, I am just trying to adjust them because I have not done this kind of sequence till now. So what should be the idea? So first of all I have written like this, and then I have taken even terms separately and odd terms separately. So now since this is a sequence, now try to write that in sigma notation. That will be very easy and you will immediately get the answer. R is equal to 0 to infinity x power 2r. Are you getting it?
Yes, sir.
Okay, so now we have done this, no problem. So what I will say, if we have sigma, let me do it step by step, no problem. Baby steps are very much required here, because if you do the things with baby steps, then obviously you will be able to solve each and everything in GATE exam very easily. So r is equal to 0 to infinity x power r, that is nothing but 1 upon 1 minus x. We already know. So now just replace x by x square. So what we are going to get? R is equal to 0 to infinity x power 2r 1 upon 1 minus x square. So this thing is solved. This part is solved. 1 upon 1 minus x square. Now we are left with this part. So how we can do it? So first write that in sigma notation. You will get more clarity. R is equal to 0 to infinity. What I am doing, see, when r is 0, then it will be 0, no problem. When r is 1, then it will be 2 into x power 1. When r is 2, then it should be 0. When r is 3, then it should be 4 into x power 3, and so on. So are you getting it? 2, 4, 6, 8, even number. So I will write it as 2r into x power 2r minus 1. You should be fluent in writing these things. So see this, when r is 0, you will get what? R is 0, you will put it x power minus 1, I think we will get, na? Okay, yeah. So 2r is also there. So it will be 0. It will be 0 only. When r is 1, then 2 into x power 1 only. When r is 2, then it will be 4 into x power 3. I think you have got it. When r is say 3, then 3 into 2, 6 into x power 5, and so on. I think you have got it. So this is my sigma notation which I have written. Now I think it's clear. So now what should be done? So now this is not according to our notations. So we will try to change it. How we will try to change it? I will simply say, see, if it is r into x power r, then everything is fit and fine. Are you getting it? R into x power r, we have done it. So numeric function is r. For numeric function r, we have written a generating function x upon 1 minus x square, the whole square. Okay, so now, okay, don't worry. So we will first try to change it in our basic notation. So what I can do, I will take 2 common outside, and I will divide everything by x. The moment I divide everything by x, what I will get? R into x power 2r. Are you getting it?
Yes, sir.
Divided by x, na? So I have taken this outside. So finally we have got r into x power 2r. So now what should be done? Now I think it's very easy. We have got our notations. So what we will say are, it's just like integration. Na? In integration, we keep on trying to do the things in such a way that we get a formula, standard formula, and then we will apply that formula and get the answer. So it's all about your common sense, and it's all about your mathematical skills, whether you will be able to do these things or not. Okay, so the more you practice, the more you get. That is the basic thing. So whatever I have told you, try to practice that again and again. You will get more clarity. Okay, so finally what I will say, r into x power r. We already know this thing. This is what? X upon 1 minus x whole square. Try to remember that. I have given you idea for AR. When AR is R, so we have got this thing, x upon 1 minus x whole square. I have given you the formula. And how we have derived it? I am just giving you a small hint. See, R is equal to 0 to infinity n minus 1 plus RCR x power r, that is 1 upon 1 minus x power n. Now we put n is equal to 1 here. So we will get r plus 1 into x power r. R is equal to 0 to infinity 1 upon 1 minus x. Okay, and then we simply shift and so on, we will get this answer. So please, you can verify your notes. R into x power r, that is x upon 1 minus x whole square. Okay, even if you are not getting it, then you should get this thing. AR is equal to R. So so everything should come to your mind that okay, AR is equal to R. We have done this kind of thing. Okay, now you will switch to this formula. From this formula, you will get this thing and so on. Just try to solve it. You will get this x upon 1 minus x whole square. Okay. So now r into x power r. Now, but what we want? R into x power 2r. So that is very simple. You just replace x by x square. So r is equal to 0 to infinity r into x power 2r. What we will get? X square upon 1 minus x square whole square. So simple. We have got the formula. Now, so everything is now over. So what we are going to get? So I will put it here. So 2 upon x into x square upon 1 minus x square whole square. So this is gone. So what we have got? what we have got, 1 upon 1 minus x square plus 2x upon 1 minus x square whole square. This is my final answer. Now the beauty lies here. By the way, let me tell you, this is one of the very difficult question which has been asked in GATE till now. So don't worry about it, sir, whether I will be able to do it or not. I am just giving you the selected questions only which are very difficult and which you cannot solve. Only those questions I have told you in the generating functions. That's simple questions. You can do them very easily. You can check all the PYQs. You will be able to solve all the PYQs. This is my guarantee. Okay, so please do not get feeling like that we will get very difficult questions and all. And 99% student have skipped this type of this question because they were not able to get all these things at the same time. Many steps are needed here. Okay, so each and everything you should be very fluent. If you are very fluent, if you know each and every formula and everything is fitted in your head properly, only then you will be able to guess these kinds of things. Okay, it's just like integration. If you have done lots and lots of practice of integration, any you can say question comes, you will be easily able to cope up with that. You will simply do small adjustments and you simply convert it into formula and get the answer. So the basic thing is all you need to do is adjustments. The more you need to do, the more you know adjustments, the more you will be able to easily solve the question. So for adjustments, you have to do lot of practice. And anyway, you see the GATE PYQs, you will be easily solve each and every question. No need to worry. But this is one of the difficult question. And see, till now our game is not yet over. We have got this answer. Many students have, see, what they were saying. Let me copy it so that you get more clarity. What we have got the answer. This is our answer which we have got. That is the beauty, na? So when professors want to give a difficult question, they can give a very difficult question. And why they are giving such kind of questions? So that nobody can get 100 marks. If somebody get 100 marks in GATE exam, so directly it's insult of IIT's professors. So they do not want this kind of thing. So obviously they will give few questions which are very difficult and nobody can solve them. Okay, yeah. So now see this. So most of the students, they have answered this. So they said 2x upon, many students have given a feedback also. Okay, so some of them were not able to solve, but if 1 to 2% students solved it, they got this as their answer, and they said, sir, we thought that GATE exam has done some kind of you can say misprinting, and they clicked this option. They said 2x upon 1 minus x square whole square, and here we are getting 1 upon 1 minus x square. So I think they have done some mistake and all, and they have given 1 upon 1 minus x. So they take this option, C option. But actually, let me tell you this thing. This is my guarantee that in GATE exam there is nothing called misprint. Okay, this paper has been checked many times and by many professors and by many typists. So do not think that you will get any kind of misprint in GATE exam. In offline, there might be some chances because of machine error and all, but this is online now. So there is no kind of misprint here. This was 2 marks question, and many of students get minus 0.66 marks just because they have done a very silly mistake and they said this is our answer. But no, this is not the answer. Okay, actual answer is A. How they have got this A? So so you have to just do small minor modifications. I am leaving this as a very small homework exercise for you. If you are able to get it, then it's really very good. Otherwise, I will tell you that in the next class. Okay, so let me give you a small hint. What we are going to do here is, see, 1 upon 1 minus x square. So I will add plus x and minus x. So what I will get, 1 plus x upon 1 minus x square plus 1 minus x upon 1 minus x square. Now try to solve and do the things, do minor modifications. I have given you the major step here, and then try to solve. Okay, you will get A as the option. Okay, so obviously this was very difficult question. Nobody can think in such a way in just 3 hours of time. The basic thing is hours. Time really matters. If you spend here 30 minutes of your precious time, obviously you will fall in a trap. Okay, so many students take this as a ego problem. Like, I have done a lot of practice, so I will be able to solve this question definitely, and they will spend a lot of time here itself, and obviously game over. Okay, so you won't be able to score good marks. So it's my request to everybody: do not take everything to the ego and all this kind of thing. If you are not able to guess the answers, simply skip it. Okay, simply skip it. So 2 to 3, at least you should scan the paper 2 to 3 times, because if you scan only once and if you are stuck in any question, you are keep on stucking here itself and you are trying to answer that question, no, I have to answer it and so on. So it might be some chance that from 50 to 65 questions, 15 questions were very very easy and you were not even able to touch them. So obviously it is very big mistake. So you have to scan the paper 2 3 times. So first, in the first scan, you simply do the questions which you already know. You simply scan the paper. In the second time, again you scan the paper and you try to spend some time on the difficult question. In third time, you are free, you can stuck on some question and all, because you have enough time, you have scanned all the paper multiple times. Okay, that is the basic approach you have to follow in gate exam. Okay, yes. So now take snapshot. I will jump to the next slide. Take this snapshot.
So
Yeah.
I also spent a lot of time after the last class on this,
Mm-hmm.
and I found that we have not learned how to generate odd series and even series. So
Mm-hmm.
that made me research on the topic, and then I attempted in a different way. So where
Okay.
I landed with the thing, I sent you a picture of my rough work. So
Okay.
um,
Okay. I,
here,
I will after class I will see that.
huh,
Okay. So we should, I think we should not waste time of our class. So
done,
after
done, sir.
class, I will clear your doubt. Okay.
Fine, sir.
Hmm. Okay. So take snapshot. I will jump to the next slide.
The next.
Okay. So you can take this also.
Just a moment, sir.
Hmm.
Done, sir.
Okay. Yes. So now we are in position to start our new topic, that is set theory. Okay. So in set theory, we have 4 parts. First is introduction to sets. Second part is relation and function. Relations slash functions. Third part is group theory. And the fourth part is poset, lattice, and Boolean algebra. So basically, we have 4 parts in set theory. Okay, and see, actually, these 2 parts are not much. They are not very much important. So if time will permit, I will cover that. Otherwise, I will leave them. Okay, and these are very very important. These are very very important. Introduction of sets and relations and functions. So we will try to focus on these 2 topics, and once they are completed, if we will have some time, I will give you idea about group theory, post lattice, and Boolean algebra, because they are very very big topics. Actually, they are very big topic, and there is no guarantee that you will find a question on these topics. So it's better is we can skip them. Okay, so we will study these 2 topics in a pretty much detail. Okay, yeah. So first we will start with introduction to set. Let me jump to the next slide, and let me tell you one more thing. Set theory is really very very easy. Only one step. Only one step questions. If you know the question, you will simply answer them. If you do not know, you will simply skip them. That is the basic idea of set theory. Okay, you do not need to do multiple steps at all. Okay, yes. So now please take snapshot. I will jump to the next slide and we will start with the sets.
Done, sir.
Okay, yes. So first of all, let me define the set. What is a set? Set is nothing but well defined collection of objects. Set is well defined collection of objects. Well defined collection of objects. What do you mean by well defined? Well defined means you are able to see, or you are able to guess very easily that which element belong to set and which element does not belong to set. Okay, so you are able to guess very easily. Okay, So you are able to predict, rather I should say we are able to predict. Guess is not a correct word, we should say we are able to predict. We are able to predict very well, very well about which element belong to set and which does not belong to set. We are able to predict very well. Okay, and that is the basic meaning of well defined. And collection of objects, so these objects can be anything. Okay, they can be numbers, they can be letters, okay, they can be persons, and so on. Objects can be anything. Okay, but they can be even sets also, because set of set is also a set. Okay, so they can be anything, no problem. Now let me give you a small idea about examples. Okay, so first example is set A. We have 1, 2, 3, 4. This is a set. Okay, so this is a set. So this is nothing but set of numbers. Okay, yes, and let us suppose we have another set B, A, B, C. I think this is very obvious, na? Circular bracket, in curly brackets we show the sets and so on. Okay, so this is nothing but set of letters. We can have a set C in which we have 1, 2, 3, 4 like this. So this is known as set of, what are these? Ordered pairs. Ordered pairs. Ordered pair means here order matters. 1, 2 is not same as 2, 1. Okay, so like this you can imagine this is at you can say 2D. So 1, 2 is point is here, but 2, 1 point will be here. Are you getting it? 1, 2 means what? X is 1, and sorry, I have done opposite way. So 1, 2 means what? X is 1, Y is 2, like this. X is 1, Y is 2. 2, 1 means what? X is 2 and Y is 1. So both are different points. Okay, so this is the basic meaning of ordered pair. Ordered pair means you can take 2D, this is X and this is Y. So obviously we cannot interchange them. So basic idea is ordered pair means I will write it here. 1, 2 is not same as 2, 1. Okay, that is the basic meaning of ordered pairs. Okay, so next is set D. Set D is having 1, 2, 3, 4 and 5. Okay, 1, 2, 3, 4 and 5. So what is this? Set of sets. Set of sets. So these are two sets. Okay, and these are elements of this. So no problem. There is no problem in these things. Okay. So let me jump to the next slide. Please take snapshot.
Done, sir.
Okay. Now if I say set of intelligent students, is it a set? No. What do you mean by intelligent? Please give me proper criteria. For example, we have a class and we will say class of students, and we will say students who are having more than 90% numbers, they are intelligent and so on. So you have to give me proper criteria. Okay, like you can say in maths, if any student is having more than or greater than or equal to 90 marks, then it is then he or she is intelligent. Okay, so you can say this is yes. And if some student is having less than 90 marks in maths, you will say it is no. Okay, so like this you have to give me proper criteria. Without giving criteria you cannot answer this. So that is the basic meaning here, well defined. So this is not well defined. Okay, set of intelligent student, this is not a set because intelligent is not well defined. Okay, so not set because intelligent is not well defined. Not well defined. Now if you define intelligence like this, then you will say yes, it is a set. Okay, so you have to define each and everything. So you should be able to predict very well which element belong and which element does not belong to the set. Okay, so next terminology or next term is cardinality. Cardinality of set. Okay, I will do that in next slide. Take snapshot.
Done, sir.
Okay, cardinality of set. What is cardinality? Number of elements in the set. Number of elements in set, or you can think of that as also size of set also. Okay, so let me jump to the previous slide and I will tell you the cardinality of the sets which we have written. Okay. So here what will be the cardinality? 1 2 3 4. Here cardinality will be 3. Here only 2 ordered pairs are there, cardinality is 2. Here only 2 sets are there, cardinality is 2. Okay, and
Yes.
cardinality of set is represented by a, like this a. Okay, let me write it properly. So I will say like this, a is equal to 4. Okay, and here I will say b is equal to 3. Cardinality is represented by mod symbol. I think these are very basic things. Okay, so yeah, I think you have taken the snapshot of this. So let me jump to the next slide. Next is, based on cardinality we have two types of sets. Based on cardinality we have two types of sets. So first is finite set and another is infinite set. Finite set is always countable. I think we have done this in TOC also. And infinite sets are of two types, countably infinite and uncountably infinite. Okay, so countably infinite means they are discrete, like apples on the table. Uncountably infinite means they are continuous, like water on the table. Okay, apple on table, water on table. Example, analogy. Okay, just to remember the things. So continuous sets examples are real numbers, irrational numbers. Countable sets examples are natural number, whole number. I think we have done that. Okay, so I should not repeat all these things here. So we have done that. Okay, so countable means discrete. That means you are able to guess which is first number, second number, and so on. But uncountable infinite set is continuous. We are not able to guess which is first, which is second, and so on. We do not know which is first real number. We do not know which is second real number. Okay, that is the basic thing. Okay, so another way of dividing the set, let me do it here itself. So another way of dividing the set is, set can be countable or uncountable. Countable can be of two type. It is either finite or countably infinite. It is only infinite, UCI only. It is of only one type. One and the same thing. Okay, you can take that also. We have studied these things in TOC.
Yes.
So let me jump to the next slide. Done?
Yes, sir.
So now we are going to start power set. This is very important topic. Many questions have been asked in GATE from this topic. So what is power set? Power set is set of all subsets of set. Set of all subsets of set. For example, if I take set A as 1, 2, 3, then its power set will be denoted by P of A. And we can also denote it as 2 power A. And what is that? Set of all subsets. So phi is subset of every set. First of all, you will write phi. Then subset of size 1, then 2, then 3, then you pick 2, 2, 1, 2, 1, 3, 2, 3. Okay, and in set order does not matter. Now please do not say set 3, 1 is different. No, 1, 3 and 3, 1 are same, because order does not matter in set. Order does not matter in sets. Okay, yes, so 2 are over, then we will say 1, 2, 3, like this. So how many elements are there in power set of A? So I think you can guess 1, 2, 3, 4, 5, 6, 7 and 8. So power set of A cardinality, or you can say 2 power A cardinality, that is equal to 8. And here A cardinality was 3. Okay, so I think you have got the answer why we are calling it as 2 power A, because cardinality will be 2 power. So I can say like this, 2 power A cardinality, that is nothing but 2 power a cardinality. So these notations might confuse you, so please try to follow these things. Oh, please try to follow these things. I think you have got this, na?
Yes, sir.
Okay. So finally, generalize I want to do. So generalize, no doubt I have done it, but proof is very simple. So this is 3 element set. So I will say you pick 0 element from this set. I think I have derived that also in permutation combinations also. So 3C 0. Then you will pick 1 element, 3C1, then 3C2 or 3C3, and that is nothing but 2 power 3 only, because we have done a very important formula, NC0 plus NC1 plus NC2 dot 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 NCN, that is nothing but 2 power n. Okay, yeah, this is one of the way. Another way of derivation can be, you will say like this, we have two possibility for each element, present absent, present absent, present absent, and so on. Okay, so present absent, and here also present absent, here also present absent. So total 2 into 2 into 2, that will be nothing but 8. So when all are absent, that is nothing but 5. When this is present and these two are absent, this is 1. When this is present and these two are absent, this is 2. When these two are present, this is absent, 1, 2, and so on. I think you have got it. So there are 2 ways to derive this thing. Okay. So now we have got the idea. So generalize, if I just to keep the things more precise, take snapshot. I will jump to the next slide.
Done, sir.
Okay. So just to keep the things more precise, I will say if cardinality of A is n, then power set of A cardinality will be 2 power n, and reason being NC0 plus NC1 plus NC2 dot 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 NCN, that is equal to 2 power n. Okay, that's why. Okay, and if I say, now let me give you a question. If I am having set 1 2 1 2 and 1 3, now can you tell me what is power set of a cardinality? It will be 2 power a, that will be 2 power 4, and that will be 16. Very simple, because there are 4 elements. Now please do not say 1 2 3 4 5 6. Do not say we have 6 elements here. Okay, this is
Yes.
1, this is 2, third, and this is 4th. So total 16 is the answer. I think there should be no doubt.
Yes, sir. Clear, sir.
Okay, now how you will represent that? So let me give you a hint here itself. Okay, batteries, I will give you questions. Okay, then I will give you the answer of how to write power set and all. Let me jump to the next slide. Please take snapshot.
Done, sir.
Okay. Now we will start some questions and then I will give you the answer of this. Okay. Yes. So let us suppose we have set A as A, B, and C. We have 3 elements. Now my question is, A belongs to A. A belongs to A subset of A. Phi belongs to A. Phi subset of A. Phi subset of A. Okay, so we will answer all these questions. So please, one by one we will try to answer. A belongs to A. Is it true or not? You simply have to check for this set A. This A should be the element. Yes, this is the element. 100% this is true. Now if I say A belongs to A, now this entire thing should be element. This entire thing is not the element. So I will simply say wrong. Now is this okay? A within bracket is subset of A. So I will remove this brackets and I will say this A should be element of this A. Yes, this is the element. So this is properly subset, 100% true. So the basic idea is, if you know A belongs to A, then you will simply say, you apply brackets and you will say it is subset of A. Are you getting it?
Yes, sir.
Because this is, see, this is the element. This is not a set. So to make it a set, you have to apply curly brackets. So now this is a set. Now this set is subset of this. Why? Because each and every element here is present here. There is only one element A here, and here we have A element. So obviously this A is subset of A. Is it okay?
Yes, yes.
Next is phi belongs to A. Please see, any phi element is here? No. You will simply cross it. Phi is subset of A. Yes. Phi is subset of every set. Phi is subset of every set. So phi is subset of A, yes. And if you want to prove why this is so, you will simply say how phi is written. Phi is nothing. Phi means nothing. So in curly brackets, there is nothing here. Nothing here. So now if you argue with me, sir, phi is not subset of A, then I will say, please give me any element here which is not present here. You are not able to give me any element here which is not present here. So indirectly I will say whatever is present here, that is here. That is nothing but the definition of subset. So phi will be subset of A, hence proved. Is it okay?
Yes, sir.
Next is phi within brackets is subset of A. Is it true or false? So I will simply apply this thing. If you are saying phi within bracket is subset of A, so I will remove these brackets and I will say phi must belong to A. Phi belong to A? No, I will cross it. Is it okay?
Yes, sir.
Okay. So now please tell me one more. Let me jump to the next slide. Take snapshot.
Got it. I'm done it, sir.
Now if I say A set is this. Okay, first tell me this thing. If A is this, that means like this. If you say cardinality of A, that will be obviously 0. And that is nothing but phi cardinality, that will be 0. Now if I say A is equal to phi within brackets. Now if I, how you will represent it? So curly bracket as it is, this phi means what? Set which is having nothing. So now please tell me what is cardinality of A?
0, sir.
No, cardinality is 1. Why?
Yes,
Because yeah, so I will say cardinality of A is 1. Why? Because this is the element. This is the element of this set, na? And this element is no problem empty set. No problem. What I will say, A cardinality is 1 because A is having empty set as element. Empty set as element. Are you getting it?
Yes, sir.
So cardinality of A is 1. Why? Because A is having empty set as the element. This is the element of this set, na? See this. If we write A like this, so what you will say? Cardinality of this set is 1. Why? Because this is containing element is a set which is having A as the element. Let me write it properly. Okay, so you should be fluent with all these things. So A is this. So I will say A is equal to this. So why cardinality of A is 1? I will say A contains set. A contains set, one set as an element. A contains one set as an element, and that set contains A as an element. Please try to read it. A contains one set as an element, and that set contains A as an element. Any doubt?
That doesn't matter, no, sir, whether that set has an element.
It hardly matters. I will simply say cardinality of A is 1 simply because A contains one set as an element. That's it. So as an explanation, I have said that set contains A as an element. So now another thing I will say like this. A is equal to phi like this, and that is nothing but like this, because phi representation is this only. So now I will copy paste it. Actually copying will take I have to copy other things also, so don't worry, I will write it, no problem.
We'll arrow it back to that.
We can take the arrow. Yes, so like this you will say, and you will say that set has no element. Are you getting it? So A cardinality is 1 because it has one set as an element, and that set contains no element. No problem. But we have an element in this set. Na? Set A is having one element, and that element is an empty set. No problem. Okay. So cardinality will be 1. Okay. So I hope now it is clear. So now let me give you another idea. So take snapshot. I will jump to the next slide.
Done, sir.
Okay. Now if I say A is equal to 5, what will be power set of A? These questions have been asked in GATE many times repeatedly. What is power set of A? So you forget about 5. You simply consider it as like this A. So what will be the power set? So you will say 5 and 5 within brackets. So simple. Okay, and we can prove it also. Power set of A will be what? Cardinality of power set of A will be what? 2 power cardinality of A. So cardinality of A is what? 1. So 2 power 1, that means 2 elements. So we have shown you 2 elements. No problem. Any doubt?
No, sir. Clear, sir.
Okay, so let me jump to the next slide. Take snapshot.
Done, sir.
Okay. So now if I say A is equal to A, B, C, 5. So now if I ask you A belongs to A within bracket belongs to A, 5 is subset of A, 5 belongs to A, 5 within bracket is subset of A, 5 within bracket belongs to A. Okay, and then I will say A within bracket, where I should write, okay, I will write it here. A within bracket subset of A and A within double bracket subset of A. So I just want you to be fluent in these bracket kind of things. These brackets confuse many students. So I just want every student should be fluent with these things. So let me answer this question. So A belongs to A. Please see, A as this is here?
No.
No. So yes, very good. I will simply cross it. So please do not say A is here. No, this is black box. Consider this as a black box. This is a set. This set is containing A. Yes. So now answer this. A within bracket belong to A. 100%. Here itself is there. Okay. 5 subset of A. Yes. By definition, we already know. 5 subset of every set. 5 belongs to A. Yes. Here we have 5. 5 within bracket is subset of A. So to prove it, what we should do? I will remove the brackets and I will say 5 should belong to A. And we know this thing. Yes, this is true. Okay. So to prove it, simply remove the brackets and you will simply say, okay, it has become actually messy. So yeah, it just keep that thing only. So 5 belongs to A means 5 should 5 subset of A means 5 should belong to A. We have done this. So no problem.
Yes,
okay, next 5 belongs to A.
Yes, sir.
How 5 belongs to A?
As similarly, so we can remove the brackets and we can say, or even we can say 5 belongs to every set.
No. No. See this. This entire thing belongs to A. Why? Because this entire thing was as it is here. Now this entire thing should be here. No, it is not there. I will simply cross it. Okay. So yeah. And next thing, A subset of A. How you will prove it? I will simply remove the brackets and I will say A should belong to A. A is not here. I will cross it. Why? Why? I will say A should belong to A, but A does not belong to A. What about this? This is subset of A. Is it true?
Yes, sir, because it is as an element present in the bracket.
So I will remove the brackets. So see this, for the subset, let me write it if something is confused. Subset, remove the brackets. For subset, remove brackets and C remaining thing should be belongs, and C remaining part belongs. Remaining part belongs to A. But rather I should write it like this. Yes, so I will simply remove the brackets and I will say remaining part belongs to A. Yes, so this is 100% correct. Okay, is it okay?
Yes, sir. Yes, sir.
So now take snapshot. I will jump to the next slide.
Done, sir.
So now let me do another question. So here A is A comma B. Power set of A will be phi A B A comma B like this. Okay. Yes, and I want to find this is a gate question. A intersection power set of A. So I think you already know a common part we have to write, na. So if
Yes,
you
sir.
have any doubt, then A is say A B C and B is say A C D. Then A intersection B will be AC.
Yes, sir.
We write like this. Yeah. So now please give me answer. A intersection power set of A will be what? Common part.
Nothing, sir.
Nothing. Very good. So answer is 5. Okay. So see this 5 not here. A within brackets. So this is not there. B within brackets. No. A B within bracket. No. Many students get confused here. Sir, A within bracket here and A within bracket here itself. No. This A within bracket is element of this. Okay. So if you want to make this common, then you have to write bracket here. Then you can say A comma B is common here. But it is not common here. I think there is no doubt now.
Yes, sir.
Okay, so and let me answer this question also. You will get more clarity. If A is A comma B and B is A B like this, then A intersection B will be again 5. Nothing is common here. Nothing. Okay. Yeah. And one more question is coming to my mind. Let me see. The question is A is equal to A B. First time here we have applied brackets. No, so now I am not applying brackets everywhere. So B is A B like this. Okay. I will apply bracket here also. Yeah, now it is a good question. So A is A within bracket comma B. B is A within bracket and B. So what should be the A intersection B?
A within brackets.
This is the answer.
Yes, sir.
No, that's why I have given you this question. First of all, you should remember A intersection B is a set, na. So first of all, you will write this as like this. Now you will say whatever is coming. So common is A, so you will write A like this. This is the answer. So how we have written 5? 5 means what? I will first apply bracket A intersection PA. I will apply brackets and now I will see which is common. Nothing was common, so I write as it is, and this is nothing but your 5.
Yes, sir.
Are you getting it?
Yes,
So
sir. Yes.
both options will be there in gate exam.
Yeah,
This also and this
means
also.
that A intersection B is also a set. It is not an element.
Yes. A intersection B is an operation, set operation. Set operation means we will get set only.
Yes.
So see this, how we have written this. So first of all, I have applied brackets and then I have said, okay, A is common, okay, C is common.
Yes, sir. Yes, sir.
First of all, we have applied brackets, na? Okay. Yes, so this is the very important point, and this type of questions might confuse you. So please take snapshot. I will jump to the next slide now.
Done, sir.
Okay. So next question is A is A within brackets and then B, C and 5. And now I'm asking A, B, C is subset of A. And then A, B, C is subset of A. B belongs to A. And then C belongs to A. And then this subset of A. So they will they will keep on twisting the questions here and there. So if you have clear cut concepts, you will be able to answer each and every question. And always it is the case that you will find twisted questions in gate. You will never find direct questions. Yes, so please try to answer this. So first thing is correct or not?
It is correct, sir.
Yes, 100%. So you simply remove the brackets. Each and everything should be element here. A, B, C. Yes, 100% correct. Next. Simply remove the brackets. A is okay. Where is B? No.
Yes.
Wrong. B belongs to A?
No, sir.
Yes, wrong. Very good. C belongs to A?
No, sir.
No. So this belong to A. What is this?
This
Sorry,
is
this is
5,
subset.
sir. When you remove
Very
the
good.
bracket, the 5, sir.
So no, this is a representation of this is 5.
Hmm.
Okay, so
Yes,
we
sir.
cannot
Not
say remove the
removing the
bracket.
brackets. Okay, sir. Okay, sir.
This entire thing, this is a representation of this is 5.
Yes, sir.
So 5 subset of A, yes, we already know
Yes.
every 5 subset of every set. This is true.
And even it is an element of the set which is being given.
Yes. 5 belongs to A also. And since you have got this point, so let me clear that also. So there might be a case that we have a set A subset of B also, and A belongs to B also. This is possible. Yes, 100% this is possible. And they will say A and B are sets. A and B are sets. Now, is it possible that A is subset of B and A belongs to B also? Same thing. Same thing is possible or not? But if you will say theoretically, you will say A belongs to B means A within bracket is subset of B. We will
So
simply say like this. No?
can we assume that B is actually a universal set?
So no problem. You can assume that. So A is subset of B and A belongs to B. How we will prove that thing?
Okay, sir.
So here what I will say, I will give you small idea. So you consider this set only. You consider this set only, and here itself we have given you idea that 5 belongs. I have got this point from here itself. Okay, from here itself I have I come to know about this point. So 5 belongs to A, and 5 is subset of A also. See this.
Yes, sir.
So I have said na A and B are sets. I have not said they are non-empty sets. I have said they are sets. No problem. Okay. Yes. So here 5 is 5 belongs to A, and 5 is subset of A also. So that means what? A is subset of B and A belong to B. This is both are true. Both are true. So if A and B are sets, both are possible.
Yes, sir.
And let me give you another interesting question. If they clearly said A and B are non-empty sets, then is it possible?
No,
A
sir.
and B are non-empty sets. So let me answer that. Non-empty sets. So let me take B as A within bracket and A. So now A set is this. So now I will say A is subset of B. Is it okay or not?
Okay,
Yes,
sir.
because you simply remove the brackets and A is here. And A belongs to B. Yes, this is also true. So again, both are possible. A and B are non-empty sets. Only then also both possible.
Yes, sir.
If A and B are empty sets, if A and B, some of them can be empty, some of them can be non-empty, then also this is possible. Okay, so there is no hard and fast rule that if some set belong to some set, then it should not be subset or and so on. It is not the case.
Done, sir.
Okay, now take snapshot. I will jump to the next slide.
Perfect, sir.
Okay, so next is, so A is 5 and A. How you will represent 2 power A? 5 within brackets A 5 comma A. So same question, I will say 5 subset of power set of A. 5 belongs to power set of A. 5 belongs to power set of A. Please answer these 3 questions. So 5 is subset of power set of A. Forget about everything. Simply say the 5 is subset of every set. So power set of A is also a set. No problem. 100% this is correct statement. Okay. Next. 5. Oops. 5 belongs to power set of A.
Yes.
Yes. 5 is an element. You can check this out. 5 belongs to power set of. This is the element. Yes, this is the element. No problem.
Yes, sir.
Okay. Yes.
Yes, sir.
So take snapshot. I will jump to the next slide. Okay, so last question. A is 5 and I want power set of A. What will be that? A is 5, that means empty set. Empty set means number of elements here are big 0. So how we will write it? I will simply apply, first of all I will apply brackets, and here I will keep on writing the elements, so this will be the answer. Like this will be our answer. Okay, so A is empty set, na? A is empty set means what? Cardinality of A is 0. Mathematically I am proving it. Cardinality of A is 0. So what about my power set cardinality? So 2 power A cardinality is 2 power A like this. So 2 power A cardinality, that will be 2 power 0. That means only one element will be there. And what will be that element? This, like this only.
Yes, sir.
Okay, so and you can think of it like this also. A, if you say like this, try to link the things. What will be the power set of A? So first of all you will write 5 and then you will write A within bracket like this. Are you getting it?
Yes, sir.
So now A is this only. Nothing
it
is there in between. Yeah.
Showed already.
So please come again.
You showed it already, sir.
Yes. So we have sorted. So okay, so that's it. So power set of A will be this. Okay, and one more question. If A is 5, like this, if A is like this, so what will be power set of A? Power set of A will be, it will contain two elements, 5 and 5 within brackets. Is it okay now? And again, do not get confused. A intersection power set of A. Yes, please tell me what will be this. This is good question. Common part.
Yes, sir. 5.
5. So how is it okay, or I should do something else?
No, sir. Understood, sir.
No. This is not good. A intersection B. First of all, we will apply brackets.
Obviously, sir. Within brackets 5. I wrote in my book actually.
Okay, 5. So no, you will find both options in GATE exam. 5 and 5 like this. This is correct. This is wrong.
In the brackets I have written, sir.
Okay, good. So A intersection power set of A, within bracket we will write 5. Okay. So yeah. So now I think everything is over. So you are I think fluent in all these things. So introduction to sets is over. And one more basic point is coming to my mind. Let me clear that also. Take snapshot. I will jump to the next slide. Okay. So if A is subset of B, if and only if B complement is subset of A complement. So it's reversed. If A is subset of B, then B complement will be subset of A complement. How you will prove it? Say this. This is your universal set. A is here and B is here. Only then you will say na A is subset of B. So now what is B complement? B complement will be this part. B complement will be this part. And what about A complement? A complement will be this big part. So obviously you can say when A is subset of B, then obviously B complement will be subset of A complement. You can check this out. Is it fine?
Yes, sir.
Okay. So take snapshot. I will jump to the next slide.
Done, sir.
Okay, and one more thing. See, this is the way to visualizations, but we can number the areas also. So like you can number this outer area as 1. You can number this area as 2. And you can number this area as 3. So what you will say, A is nothing but 3. B is nothing but 2, 3. So A, obviously A is subset of B. Now what about my B complement? B complement is 1. And A complement is 1, 2. Okay, so that's why B complement will be subset of A complement. Okay.
Understood, sir.
Okay, let me jump to the next slide. Take snapshot.
Done, sir.
Okay, so now we are going to start our new topic. Introduction to sets is over. Now we are going to start relations. Okay, so let me give you a small idea. We have a set A which is having 3 elements 1, 2, 3, and we have a set B which is having 2 elements, say 1 A comma B. So here number of elements are 3, here number of elements are 2. So we will write A cross B, that means cross product. Cross product, how you will write? So you will pick one element, okay, one this, then 1B, then 2A, 2B, 3A, 3B. So we will write like this: 1A, 1B, 2A, 2B, 3A, 3B. And these are ordered pairs. These are ordered pairs. So here order matters. That means it is not same as A1. 1A and A1 are different. I have given you the idea: x, y and y x point 2D plane. That is the basic scenario here. Okay. Yes, so what about my B cross A? How B cross A will look like? So first you will pick element of B and then you will match it them with A. So B cross A will be A1, A2, A3, B1, B2, B3. So now clearly you can see from here A cross B is not same as B cross A,
Yes, sir.
but their cardinality is same. A cross B cardinality, that will be same as B cross A cardinality, that is nothing but 6. And how we have got 6? So you can say like this also: A cross B cardinality, that is equal to B cross A cardinality, that is equal to A cardinality multiplied by B cardinality. I think that is very obvious things. Any doubt?
No, sir. Understood, sir.
Okay. So now let me write the formal definition of A cross B. So what is A cross B? A cross B is nothing but x comma y such that x belongs to A and y belongs to B. Is it okay?
Yes, sir.
Hmm. So similarly, you can say B cross A will be what? Again x comma y, but now x belong to B and y belongs to A. Now do not say, sir, they are equal. No, no, no. Here x belong to B and y belong to A, but here x belong to A, y belong to B.
Yes, sir.
Okay, so this is the formal definitions and nothing more than that. Okay, so and we call this which we have written A cross B or B cross A, these are known as universal relations. These are known as universal relation. So universal relation means, so every relation from A to B will be subset of A cross B, and every relation from B to A will be subset of B cross A. Are you getting it? So what do you mean by this? So every relation from, direction is very important, from A to B will be subset of A cross B, and every relation from B to A will be subset of B cross A. Okay, yes, so that is the basic meaning. So relation is nothing but, if you simply say what is a relation, relation is subset of A cross B, that's it. Okay, and relation is obviously defined when we have two sets. So relation means what? How these elements are related, that's it. Okay, yes, so that's how relation term has been coined. take snapshot. I will jump to the next slide. I will give you more idea about it.
Done, sir.
Okay. So what universal relation is saying? Universal relation is saying every element of A is related to every element of B. Universal relation means every element of A is related to every element of B. Universal relation means this thing. Okay, and a normal relation means we will see which element of A is related to which element of B. Okay, so let me write it. Relation from A to B means which elements of A are related to which elements of B. Okay, and similarly I will copy this. Relation from B to A. Relation from B to A means which element of B are related to which element of A. Take snapshot. I will jump to the next slide.
Done, sir.
Okay, so now we will answer first few numericals and then we will start other topics. So A is 10, B is 5, A cross B cardinality, you have to tell me. So answer is very simple, simply multiply them. So A cross B cardinality, that will be equal to A cardinality multiplied by B cardinality. 10 into 5, that is 50 is the answer. Okay, so many times question have been asked, so please tell me cross product is commutative or not? Cross product is commutative. Commutative means A cross B is same as B cross A? No, I have just told you. Okay, so
Theory.
So cross product is please tell me.
Nothing, sir.
A cross B is not same as B cross A. Okay, similarly as per the elements. Okay, and see this, not equal to means it may or may not be equal. You have to see this. Not equal means may or may not equal. May or may not equal. For example, when A and B are same sets, then obviously A cross A will be equal to A cross A. Okay, so not equal to means may or may not equal, but equal to means always equal. Equal to means always equal. Is it okay?
Yes, sir.
Okay, so cross product is commutative, false. This statement is false. Now next question is cross product is associative. Cross product associative. Associative means can I say like this, A cross B cross C, that is same as A cross B cross C? No. For example, you can take elements from a set A. We have one element, so 1 2 3 like this. Is it same as 1 2 3? No, obviously they are different. Okay, so a cross product is neither commutative nor associative. This question has been asked. So finally what I will write, cross product neither commutative nor associative. That is very important point. Okay, yes, so now you can take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now I will give you examples of relations. Okay, so for example, same set what we were having, let me copy that. because without giving set I cannot define relations and all. Now obviously I have to give set. So set A is having 3 elements 1 2 3. Set A is having B elements 1 2. A cross B I have written, B cross A I have written, so I will not write that again and again, and I will simply define a relation R is subset of A cross B. That is the basic thing. So now you can define any relation R1 as 1 comma A. Very simple. You can define relation R2 as 1 comma A 2 comma B. Okay. So and another relation you can define phi also. Phi is also relation. You have taken nothing. Are you getting it now? Okay. If you have any doubt, I can copy that A cross B part. Yes. So I will paste it here. Yes. So A cross B is with us now. So now we will say you simply take any subset of it. That's it. You take any subset of it. That will be a relation. You take just one element like this. You take two elements 1 comma A 2 comma B 1 comma 2 comma B. Yes, this is also relation R2. R3 empty relation. That is also relation because why? A cross B is after all a set. Yeah, very good. Phi is subset of every set. So obviously it will be a relation. And this is known as this is empty relation. Empty relation. And empty relation is smallest relation possible. Smallest relation possible. Okay. Yes. And one more thing. If I say R4 is 1 comma A, is it a relation? No. It is not a relation. Why? Because subset na 1 comma A is not subset of this. So you have to write brackets like this. That's why I have written here brackets. Okay. So R4 is now okay. Yes, so now I think you have got the point. So smallest possible relation is phi. What is the largest possible relation? Largest possible relation is A cross B itself. So I can write R5. Okay, I can write R5 is equal to, I will copy paste it. Same thing. So that is nothing but A cross B only. So smallest, so as it is I can take, na? Because every set is subset of itself. That's why. Okay. So smallest relation is phi. Smallest is phi. And largest is A cross B itself. Is it okay?
Yes, sir.
Yes. So now few basic questions we will answer. Take snapshot.
Phi, we have to just assume that it is always there. We need not
Yeah,
write it.
always there. Yes. It is always there. Yes, 100%.
It has got its count also, no, sir? When there is phi.
Yeah.
When it has its count, do we need to write it in the set and count it as the element? No.
No. See, if you want to write it as an element, how you will write it? That is interesting question. See, if a set A is empty, okay, let me write it. If set A is 1 comma 2, and I will say set B is equal to 5, and you will say B is subset of A. This is true. If B is subset of A, now you have to write each an element of B as element of A. Now what is B? B is this. So this is here we have nothing. So you have to write nothing in A. Nothing in A is already there. So you cannot write it. Are you getting it?
Yes.
Okay. So like this you can visualize the things. So B is subset of A means every element of B should be there in A. But there is no element of B. There is no element in B. So how I will write that? I cannot write it. You can simply assume it is just like an air. Air is here also. That's it. Okay. Yes. Take snapshot. I will jump to the next slide.
Okay, sir.
So now simple. I will simple questions from combinatorics. How many relations are possible? How many relations? From here itself. So see 1, 2, 3, 4, 5, 6. So we need to find set of all subsets of this A cross B. That is nothing but power set. So 6 elements are there. So 2 power 6 relations will be possible. So simple. So number of relations possible will be 2 power 6. I hope you have got it.
Huh.
That is nothing but 64. Why? Because number of subsets. Number of subsets of A cross B. And that is nothing but power set of A cross B cardinality. And that is nothing but 2 power A cross B cardinality. And that is nothing but 2 power 6, 64. These are the baby steps which I have done. Okay. So now I can generalize set A is having m elements, set B is having n elements. So number of relations from A to B. Number of relations from A to B. So first of all, how we will find number of relations? So first of all, I have to find cardinality of A cross B. A cross B cardinality will be cardinality of A multiplied by cardinality of B, that is m into n. And the number of relations will be what? 2 power cardinality of A cross B. It comes out to be 2 power m into n. This is my answer. Any doubt?
Understood, sir.
Okay, so 2 power mn is the answer. Similarly, they can give you question number of relations from B to A. Same answer, same answer. If you write, if I want to write it, then it is very simple. I will say number of relations from B to A. Number of relations from B to A. So from B to A, so I will say B cross A cardinality. I am doing by baby steps. B cross A cardinality, that will be n multiplied by m. So it will be 2 power B cross A cardinality, that will be 2 power n cross m. And obviously we know n multiplied by m or m multiplied by n, one and the same thing only.
Yes,
Is it okay?
sir.
Take snapshot. Yes, then I will jump to the next slide.
Perfect, sir.
Next question is, we have say set A, we have something in set A. Set B also we have something. Relation is subset of A cross B, we already know. So the question is, if we say relation X, that is X comma Y, such that Y is equal to X square. I have given you a relation. Now question arises, I have not given you the sets A and B. So from where you have derived this relation? So directly and indirectly I want to say parent sets are missing. Parent sets are not given to you, and I have directly given you this relation. So how you will imagine them? So obviously we will take them as real numbers. Okay. So you will simply say X is subset of R cross R. So when parent sets are missing, you will consider them as real numbers. Okay, so how relation X will look like? You will simply say X comma Y, Y is equal to X square, na? So 1 comma 1 will be there, 2 comma 4 will be there, 0.1 comma 0.01 will be there, 1 by 2 comma 1 by 4 will be there, and so on, dot 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 dot, infinity. So this is the relation. Any doubt?
So as it is written 1 comma 1, because both are real numbers, we can repeat that also. One is from one side.
No, Y is equal to X square. Second number should be square of this.
Okay, sir.
1 is square of this. So 4 is square of this.
Sir.
Point. So 1 by 4 is square of 1 by 2. Relation I have given you, na?
Sir.
So take snapshot. I will jump to the next slide. So relation means what? How the elements are related. That's it. Okay.
Yes.
So let me jump to the next slide. And if you want to give up, I should give a pictorial representation. Then I will say like this. Anyway, I have to show all these things later. But let me give you a small idea. 1, 2, 3, 4 elements, and B is having say 5, 6, 7, and I say relation R is 1, 5, 3, 6, 4, 6. I have a relation like this. Okay, and let me write there another thing. Say 3, 7. This is a relation given to us. So what do you mean by this? So this means that in a set A, 1 is related to 5. And in from the set A, 3 is related to 6 also, 3 is related to 7 also, and 4 is related to 6. Like this, we can write, and pictorially in set format, I will say like this: 1, 2, 3, 4, 5, 6, 7. 1 is related to 5, 3 is related to 6, 4 is related to 6, 3 is related to 7, like this. So now I think you have got more clarity about what exactly relation means. Relation means how the elements of set are related to each other. That's it. So you can consider them there as say students in the class, student 1, 2, 3, 4, and another class student 1, 2, 3. So student 1 is friend. You can consider relation as a friend. So you will say 1 is friend with 5. So that means 1 is related to 5. 3 is friend with 6 and 7. So you will say okay, 3 is friend with 6 and 7. Okay, 4 is friend with 6, 4 is friend with 6, like this. So relation means how simple relation, like in day to day life we have a relation between humans also.
Yes,
Okay,
sir.
so that is the basic thing. So these are the two sets. So relation means how the elements are related with each other. That is the basic meaning. Okay.
Yes, sir.
Yeah, so now take snapshot. I will jump to the next slide. So we have got more clarity about what are exactly our relations, and now we will dig deep into this chapter, and I will give you the syllabus. What are the topics, what we are going to study in this chapter and all. Let me jump to the next slide now.
Done, sir.
Okay, so now we have started our new chapter, that is relation chapter. And this relation chapter, we are going to study total 10 topics. The very first topic is introduction to the relations. Introductory part is over. Next topic will be domain and range. This is very important. Finding domain and range of relations. Questions has been come many times. Next will be R relative sets. One or two times question have been asked on this topic also. Next topic will be operation on relations. Operations on relations. See, actually relations are nothing but sets only. Relation is subset of A cross B, na? So all the set operations like union, intersection, set difference, and all, cross product, and so on, we can do anything with the relations. So we will study them one by one. Operations. Okay. Then after operations, we will start representation of relation. Representation of relation. How relations are represented. Okay, so there are total 8 ways which we are going to study. One by one we will study them. One of the way I have shown you here itself, like this. Another way is this only, listed form. Okay, this is a set form. We will see total 8 notations are there. I will give you the idea about all these things. Okay, after representation we will start properties of relation. Properties of relations, I think you have heard of it: reflexive, irreflexive, symmetric, anti-symmetric, and so on. Okay, so let me write it in the shortcut manner: reflexive, irreflexive, symmetric, anti-symmetric, asymmetric, and transitive. Total 6 we will study, and these properties are obviously very important. Almost every year one question you will find from these properties. Okay, so next topic which we are going to study is counting relations. Counting relations. So that means here I will answer how many reflexive relations are possible, how many irreflexive are possible. That is also very important. Okay, so how many question, like how many are, how many IR, and so on. We will study that. Okay, then we will jump to closure. Closure, reflexive closure, symmetric closure, and so on. We will study that. Reflexive closure, symmetric closure, and so on. We will study that. Okay, then we will start equivalence relation. Equivalence relation is very important. Many times question has been asked directly, many questions, like how many equivalence relations are possible, equivalence classes, and so on. So this is a big topic, we will study that, don't worry. And then we will study interpretation of powers of relation. Interpretation of powers of relation, like r power n. What do you mean by r square? What do you mean by r cube? What do you mean by r power minus 2, and so on? So we will study that. So total 10 topics we have to study. Topic chapter is huge, but it is very easy. Okay, one by one we will cover all these topics. Take snapshot. I will jump to the next slide.
Okay, sir.
Okay. So now next topic is domain and range. The introduction is over. Domain and range. So let me start that topic. Domain and range of relations. So let me tell you the idea. A is say 1, 2, 3, 4, and B is say A, B, C, and I have given you a relation 1 comma A, 2 comma B, 2 comma C, like this. So domain of R, I will write like this. Domain of R like this. So domain of R is first, 1, 2, again 2. Obviously, we will not take it because it is a set. Domain of relation is a set. So 1, 2, 2. 2 times 2, I will take it one time. 3, 2 times, I will take one time. So 1, 2, 3. Okay. What is range of R? Second element. A, B, C. A, B repeated. Don't worry. Don't take them. A, B, C. Okay. So domain of R is 1, 2, 3. Range of R is A, B, C. Is it okay?
Yes, sir.
Okay. So now from common sense, I can derive one thing. That is for sure. Domain of R will be subset of A.
Oh,
And range of R also subset of B. So no doubt we have taken entire B here. It is by chance. One of the relation I have shown you. How many relations are possible by the way? 4 into 3. 4 3 is a 12. So 2 power 12. 2 power 12 is 4096. So 4936 relations are possible. See this. Cardinality of this is 4, this is 3. So 2 power 4 into 3, that is 2 power 12. Total 2 power 12 relations are possible. 2 power 12 is 4096. 4936 relations are possible. From these 4936, I have given you only one relation. And for that relation, I have found domain and range. So for each and every relation, 4096, you can find domain and range and all. Obviously, you will not count all, but we can find, that is for sure. Okay, so domain means first, range means second. Make the set, game over. First, make the set 1, 2, 3. Second, make the set. That will be range. So domain is subset of A, range is subset of B. That is for sure. Okay, take snapshot. I will jump to the next slide.
okay, sir.
Yes, but obviously finding domain and range in GATE exam you will not find this type of question. This is very easy. Anybody can answer them. So in GATE you will not find this. In GATE exam you will find a relation on real numbers, natural numbers. That means which you cannot list down, which you cannot see from your eyes. You can see this from your eyes. You can simply answer that. GATE will not answer ask such question. That was just basic to clear your basic things. That's why I have shown you. Now I will jump to the real questions which have been asked in GATE. Let me jump to the next slide.
Yes, sir.
Okay. So the next thing is, now they will say like this. We have a set S in which we have a relation x comma y such that y is equal to x square. Y is equal to x square. Nothing is given, so you will simply consider S is subset of R cross R, real numbers. So now they will ask you what is the domain of S and what is the range of S. So now domain means first element X. So now you try to figure it out yourself. See, I will write like this: R cross R. So first R is X, second R is Y. That is for sure, na?
Yes.
Any doubt here? Yeah.
Yes.
Okay. So now what values of X I can put? Then I can find the value. So what values of X can I put here? So the question directly and indirectly means, can I put any real number here? So if I can put any real number, so I should say square of that real number should be a real number. That is for sure. Square of every real number is a real number. So no problem. I can input any X here and output Y will be definitely a real number only. Any doubt?
No.
So now I can input any. So directly and indirectly, domain of S will be all the real numbers. Okay. So now can you tell me Y output? You can put here any real number, means you can put positive, negative, 0, whatever way you want you can put. But what about my y? Can y be negative?
No, sir.
Never negative. It will be always positive. Can it be 0? Yes, 0 square is 0. So a range of S, many students will write R plus, but no, R plus is not the answer. You should say union with set like this, 0. And you should not say like this, R plus union 0. No, this is wrong. 0 is an element. It is not a set. So write it in a set format like this. Because union can be done by two sets. This is one set, this is another set. You are doing union of these two. So write like this properly. So range of S is this.
Yeah. Do we need to write them in the brackets, sir?
This entire thing?
Huh.
No need.
Okay.
R plus union S. So R plus is set and union with this. So see this. If you face any kind of difficulty, try to focus on simple things. A set is 1, 2. B set is 3, 4. What you write? A union B you write, na?
Huh.
So you do not write apply brackets here, na? So that's it. Okay. So R plus union 0. This is my final answer for the range. Now let me jump to the next question. Take snapshot. I will jump to the next question. Okay. So same type of question only. I am saying S is equal to x comma y such that x is equal to root y. And it is on R cross R only. Okay, S is subset of R cross. Nothing is given. I am saying so that's why it is R cross R. Nothing is given to you in GATE exam. So you will simply consider them as a real numbers only. So now we want to find the domain of S and range of S. Yes. So how we will write? I will write it like this: R cross R. So X is this and Y is this. So now I have to input this now. Please try to focus. X is in terms of Y. So what is free? X is free. So I should supply value of Y. So Y is second, X is first. So now I will say this is input and this will be my output. So now supply any real number here. Can I supply any real number here? Can I supply -2?
No, sir.
No. So negative real numbers not allowed. 0 is allowed? Yes. So again R plus union 0. So this will be what? Second is what? Range, na? Second is range. So range will be R plus union 0. What about my domain? Domain will be what? So when I put y to be 4, what I will get? I will get 2 as the answer or plus -2? Plus -2, na? Square root of 4 is what? Plus -2, na?
Plus or -2, yes, sir.
So why this is so? Very basic question. Why this is so? That is very obvious. See, x is equal to root 4. X is equal to root 4. So that means what? X is equal to 4 power 1 by 2. Now if I square, I will get x square is equal to 4. So directly indirectly I want to say x square is equal to 4 means what? Now I can take x to be 2 also. 2 square is also 4 and -2 square is also 4. So that's why I have to write plus -2. Root 4 is plus -2. So obviously I will get positive also, negative also, everything will be there. So entire real numbers, all the real numbers I will get it. That is for sure.
Yes, sir.
Okay. So now take snapshot. I will jump to the next slide. Done?
Done, sir.
Okay. So next question is S is equal to x comma y such that y is equal to 3x plus 1. This is the relation. And I think you can write now, if I want to give you an idea how this relation will look like, you can easily say S will be, you can take any value. X is when x is 1, y will be what? 3 into 1 plus 1, that is 4. When x is 0.1, you will say 1.3. When x is 2, you will say 6 plus 1, 7. 2 is related to 7 and so on. So are you getting it now? So, and nothing is given, so obviously you will take it as a subset of real number cross real number. So you have entire real number set, entire real number set. So here if you pick one, that one will be related to 4. Are you getting it?
Yes, sir.
So here 1 is related to 4. Here you have picked 0.1, 0.1 is related to 1.3 and so on. So relation is giving you idea which element of first set is related to which element of second set. So we have given you this kind of thing. So as S is subset of R cross R, that is for sure. Now same question, domain and range. R cross R. So which is dependent on which? So X, Y is dependent on X. Now, so first of all, you will supply here input and you will get here output. So what can I supply any real number here? Yes, 3 into real number. I can supply any real number and answer will be any real number. So obviously domain and range will be all the real numbers. Domain of S, sorry. Domain of S is entire real number and range of S is also entire real number. Take snapshot. I will jump to the next slide. Okay. So now this is important question. So now see carefully. S is X comma Y and they are saying Y is equal to 1 upon X minus 3. Nothing is given, so we will take subset of R cross R. So now tell me domain and range. So Y is dependent on X. So obviously I will put here X, any value of X, and I am expecting some output. So please tell me, can I put any value of X here? No. 3 I cannot put because 1 upon 3 is not a real number. Oh, sorry, 1 upon 0. We will get now 1 upon 0. 1 upon 0 is not a real number. So I cannot input X to be 3. I cannot put X to be 3. Otherwise, I can put any value. So domain.
Even if X is 2, so we get minus 1, no problem.
So real number minus 1 is there, na?
In the denominator also, we just consider that as to be.
No, don't get confused. 1 upon minus 1 is nothing but minus 1 only. 1 upon minus 3. 1 upon minus 3 means what? If you have any doubt, you keep on doing the things. 1 upon minus 3. So you simply divide by both the sides. So you will get minus 1 upon 3. No problem. Okay, so domain of R is for sure I cannot pick 3. Rest any real number I can put. So R minus 3. That is the domain. Now range. How you will find the range of R? That is again a good question. So for that, I am not able to guess from here itself. So what should I do now? I will try to express X in terms of Y and do the reverse process. So what I have to do from here, I will try to find, see, I will say X minus 3 is 1 upon Y. I simply reverse it. Is it okay now? I simply reverse it. So X is equal to 1 by Y plus 3. Yes. So now R cross R. So now X is in terms of Y. So I will put Y as first my input and then I try to find X as the output. Now see, can I put any input Y here? No, I cannot put 0 because the moment I put 0, it will be 1 by 0. Now X will not be a real number because X should be a real number. Na? So 1 by 0 will not be a real number. So except 0, I can put anything. So R minus 0. This is my answer. So have you got it? If you have any kind of confusion, please come again.
It is only in your writing mistakes. Domain of S and range of S is still in. So in answer is domain of S.
Okay. Domain of S, yes. Domain of S, range of S.
I understood this.
Okay, yeah. So working rule for this type of question is whatever is there in another terms. So you try to answer that first. So Y was in terms of X. So I input X and then I try to find the output Y. So input is X. So I have got the idea of domain. For range, I was not able to guess from here itself. So I converted that and I tried to find Y in terms of X. And then I input the y and try to find the output. So finally I've got that y I cannot put 0, and finally we have got this answer.
That's it.
Okay. So now take snapshot, and from here, without doing this thing, you cannot guess that it y cannot be 0. We cannot guess it.
Yes, sir.
Okay, so take snapshot. I will jump to the next slide.
Copied, sir.
Okay, so one last question. S is equal to x comma y such that y is equal to log to the base ex. So how we will answer this question? So you should have idea about logs and all. So r cross r, you will study that in aptitude. Don't worry. If you have less idea, you will study that. Okay. So what? Y is in terms of x. So first I will input this x and try to find y as the output. So now, can I put any value of x? No, only positive values. I even cannot put 0, and I cannot put negative because log is not defined for negative numbers. You should know these things. So we can, so 0, negative, not allowed. Only positive numbers are allowed. So I will simply say domain of S will be R plus. What about the range? For range of S, so I cannot guess that. So for that I will simply reverse it. So y is equal to log to the base ex. So it indirectly means e to the power y is x. You know these things?
No, sir, I don't know.
Okay, so don't worry, you will study that in aptitude. So log to the base ex is equal to y, so x is equal to e to the power y. Okay, so finally now it is very easy. So r cross r. So now you will input y and you will get the output. So now please tell me, can I put any input of y here?
Not
Obviously, yeah, negative we can put also. E power minus 2, e power minus 3, e power minus 4, that is allowed. That will be a real number, na?
Okay, sir.
Okay, forget about e is 2 point something, na? So you can take any real number. 3 power minus 5, it is a real number. 3 power minus 6, real number, and so on. So obviously I can put any value of y, no problem at all. But from here also you can guess. So you can put any value of y, but x, what you will get? 3 power minus 6 or 3 power minus 1 lakh. Whatever you put, it will be definitely a positive number, na? Can it become negative? No, it will become negative only when 3 will become negative, but 3 is not negative, 3 is positive only. So 3 power minus whatever number you will put, you will get a positive as answer. You will never get negative. So that's why I have put domain of S as positive real number. So if you do not have idea about this log, so from here you can guess. So this is the definition. Y is equal to log to the base ex means e power y is equal to x. This is the definition of log only. So y will be input and x will be our output. So y I can put anything. So range of s will be entire real numbers, but output will be only positive real numbers. I think you have got it.
Yes, sir.
Okay, and it's not required, but I am telling you because if you get good rank in GATE, then obviously you have to face interviews in IITs, and in IITs they will definitely ask you questions about drawing the graph. So they will simply say you, please try to sketch graph of this. So you should know how to sketch the graph. So when x is 0, then y will be 1. Sorry, when y is 0, then x will be 1. So like this. Don't worry, you will study that in aptitude like this. Okay, so from here also you can guess. So this is log x graph. Okay, so log x graph is this. So x is this, and here we are writing log of x. Okay, so log x can be positive, negative, but x is always positive like this. So you can from here also you can find you can put any value. Okay, so you can go like this. So you might face that it will never touch a 0 obviously. Okay, but yeah, so it will never touch 0. That's why I have taken r plus. Okay, and it can go till here. So see this, domain is only positive real numbers. Range is what? This is the range. This is all the real numbers. You are covering all the real numbers. This is the graph of log x.
Okay, sir.
Okay. Yeah, take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next topic we are going to start is R relative sets. So two topics are over. Domain range is over. Now we will start R relative sets. R relative sets. So it is represented by R of x, just like functions only. So we have A to be 1, 2, 3 and 4. A, B, C. R is 1A, 2B. Randomly I am writing, say 2C, 3A, 3C. So this is your relation R. Okay. So now they will directly ask R of x is R relative sets means R of x. So they will say R of 1. Tell me R of 1. So you will say it is set of elements with which one is related. One is related to A. No other else. So A. R of 2. Set of elements with which 2 is related. 2 is related to B. 2 is related to C. B comma C. R of 3. Set of elements with 3 is related. AC. So for R of x means set of elements with which x is related. I think it's very easy. Any doubt here?
No, sir.
Okay. So now if R is given to us, we can find R inverse also. R inverse means R power minus 1. So you simply swap them. R inverse will be A1, 2B, B2, C2, A3, C3. Now they can ask you R inverse of A. You will simply find, say, set of elements with which A is related. 1, 3. R inverse of B. You will say 2, 2 only. R inverse of C. 2, 3. Okay. Yes. And one more thing. Since set A is having 4 elements, so I can find R of 4 also. No doubt here it is not given. No problem. I can write R of 4. So what we will say 5. That means what? 4 is not related to any element here. Okay. Similarly in R inverse, okay, everything is covered. ABC is covered. If we have any element D also here, so I will say R inverse of D will be 5. Is it okay?
Yes, sir.
Now we will formally define it. How you will define formally or mathematically? R of x. R of x is nothing but y such that x is related to y. Or x is related to y, you can write like this also mathematically. You can write like this also. R of x is nothing but y such that x comma y belongs to R. This is familiar notation to you. X comma y belong to R. And this is a new notation for you. Is it okay?
Yes, sir.
Okay. So now interesting question is coming. Union of for all x belongs to A, R of x will be what? So I just want to find R of 1, R of 2, R of 3, R of 4, union of all these. You will get what? For a set of elements to which all these elements are related. That is nothing but range. So we will get range of R. Are you getting it?
Sir.
Similarly, if I say union of for all x belongs to B, R inverse of x, what we will get? So from here I will get domain of R. Please say this.
Yes, sir.
In R inverse, see, if we have to focus in R inverse we are doing, so we will get domain of R. In R we are doing range of R. R, this is R. Domain
Yes,
of
sir.
R we will get. Okay, so take snapshot. I will jump to the next slide.
Okay, sir.
Okay, so the next thing is we have a set A is equal to 1, 2, 3, 4. We have a set C 1, 2. Okay, so here what? So directly I can say C is subset of A. That is C is subset of A. Now I can say like this also. What is R of C? R of C will be nothing but R of 1 union R of 2. R of 1, you can check this out. A union R of 2 BC. So union of these will be what? So finally R of C will be equal to ABC. So formally, so directly and directly, what I have proved here, that there is you can say there is not compulsion that you should write only one element here. You can write any subset of A also. It is not that you can find R of 1, R of 2, R of 3, R of 4. You can find R of C also. That means any subset of A also. And for that, definition is this. So formally, what I will define R of C is nothing but Y such that X is related to Y for all X belongs to C. Is it okay?
Sir.
R of C is nothing but all those Y's such that X is related to Y and for all X belong to C. Okay. Take snapshot. Please speak.
Those which are like as C is a subset of A, so that's why.
Yes. Okay, so let me jump to the next slide. Yes, so R is a relation from A to B. If I say R is relation from A to B, we will write it like this, A to B, like this. Okay, so question number 1, what is R of A itself? See, I have told you now, we can write any subset. So A is subset of A, so I can write R of A itself. R of A means what? All those elements of A which are related to some elements of B. So what we will get? Range of R.
Yes, sir.
Okay. Question number 2, R inverse of B, obviously domain of R. Question number 3, R of domain of R. And question number 4, R inverse range of R. R of domain of R, obviously range of R. R inverse range of R, domain of R. Please let me know if any of you is having any doubt here.
Nice, sir.
So see, 1 and 3 are same type of question. 2 and 4 are same type of question. Is it okay now? And domain of R is subset of A only. So see, if something is missing, so that will be represented by 5. For example, like see this here. R of 1, R of 2, R of 3, R of 4. Union of all these, that is nothing but R of A. R of A is nothing but range of this relation. Range of this relation is A, B, C, D. A, B, C only, A, B, C. This is the perfect example. Okay, so if you take only R of 1, 2, 3, you simply skip 4. So if you take 1, 2, 3 only, that is nothing but domain. So R of domain of R, that will be range of R. Yes, please let me know if anybody, if you have any doubt.
Nice, sir. Understand.
Yes, so there is very minute gap here, A and domain of R. So actually A and domain of R are not same. Domain of R is subset of A. But if some A element of A which is not in domain of R, you have taken that, then R of that will be 5. So you simply ignore it. So finally we will get range only. Yes. Example this only, like 4. Yes. So now I think it's fine. So okay, take snapshot. I will jump to the next slide.
Done, sir.
Next is actually a big question. We have to spend time. So time is over. So okay, no doubt. We will keep here itself. We will start from here in the next class. Okay.
Yes, sir. Thank you so much.
Okay. Then. So we will meet today itself at 8:50. Again, we have a class in night. Okay. Okay then. Bye bye.